Hello.
Hello.
How you doing today, Mr. Dean?
Doing all right. How about you guys?
I'm a little tired, but I'm still living.
That's a good sign. Let's see.
Well, I'm in class. That's weird to say. Jesus.
No, I'm not in bed. I'm in class.
Jesus. Excuse me.
All right. So we'll wait. See how many more tricklers we get in here. And we'll start up in a minute.
Ah, damn it, me myself.
All right. Well, guess it's going to be a light showing today. All right. So today we're going to kind of do a quick review of what we had left off doing right before we went on break. And then we will kind of touch on something new here in a second. So so last time, before we started the break, we were going over lines and equations of a line. The most common one that we see is y equals mx plus b. Hold on. My video is being mirrored. There we go. Try that out. So y equals mx plus b, and we also talked about how to find the slope. Was the first thing. So this was our slope formula, y2 minus y1 over x2 minus x1. I also wrote it like this. Delta x. Nope. Sorry. Delta y over delta x, because it's the change in the y variable divided by the change in the x variable. And this is how we find slope. We also had discussed some things related to what different slopes mean.
Polynomials.
So for a line to be parallel to another one, we said the slope was equal in both lines. So whatever the value of the slope is for one of them, to make a parallel line, you just make a new equation with the same slope and a different y-intercept. And then for perpendicular, we had that the slopes are completely opposite of each other. So one slope is the negative inverse of, or the negative reciprocal of the other one. So this is the basic overview of the kinds of things that we went over before the break. And now we're going to expand this knowledge just a little bit. And we're going to move on to not linear equations, but linear inequalities. So if the equation of a line is y equals mx plus b, all we have to do to make this an inequality is change the equal sign to one of these little symbols. So remember, we had greater than, less than, greater than or equal to, and less than or equal to. So our method before for solving inequalities with one variable, so we might have had something like, I don't know, x squared is I'm going to do that a lot, we can already tell. X squared minus 4 greater than 0. The way we solved these is, first step, make it an equation. So this would become x squared minus 4 equals 0. The next step is we solve that equation. So if you solve this, get x squared equals 4, and you get x equals plus or minus square root of 4, which is positive 2 and negative 2. So when we have these two solutions, what this does is it creates boundaries. And we have to test all of the different zones created by these boundaries. So once we got our solutions from there, we created our 3 boundaries. One of them was negative infinity to the lower boundary, which is negative 2. Then negative 2 to 2, and 2 to positive infinity. And then we tested a point in each one of these boundaries. We look to see, does that point work? So, for example, let's maybe look at 10, 0, I'm sorry, negative 10, 0, and 10. So if we plug negative 10 into this equation, we get 100 minus 4, which is greater than 0. So that one works. If we plug in 0, we get 0 is greater than 4, which is not correct. And we plug in positive 10, we find that this one does also work. So now that we have our bounds, we say that this bound, this location, or all the points in this region work. All the points in this region do work, and none of the points in this region work. So from there, what happens when we get to two-dimensional inequalities? Y equals mx plus b. The solution method is the exact same thing. So let's take an equation. Let's say y is greater than 2x plus 1. Well, step 1, make it an equation. Y equals 2x plus 1. And this is where things get a little bit confusing to a lot of students, especially algebraically, because the next step is solve this equation. So up to now, using algebra, you just get one of the variables by itself, and then you see what that leads to. But now it's not quite as simple. We have to think about what do we actually mean by a solution to an equation. Sorry, get my computer down. So when we started talking about graphs of equations, we said that a graph is every solution to that equation. So in order to solve this, what we really need to do is graph it. So the way we graph these things is first I plot the y-intercept. The y-intercept is 1. So plot that point, 0, 1. Next up, you have to plot the, I go over one space and I go up or down whatever the slope is, 2. I'll go over 1 and we go up 2, 1, 2. So our line will look something like this. So in the previous set, we said that the solutions create boundaries, okay? So on one side of that boundary, the inequality works. On the other side, it doesn't work. So the same exact thing has happened here, where all of these solutions in this line create a boundary between this side of the graph and this side of the graph. So now we just have to pick a point on each side and see which one works. Well, we have an easy point, which is at 0, 0. And let's plot a point, I don't know, 2, 2. Sounds good. So you plug in 0, 0 to this, you get 0 is greater than 2 times 0 plus 1, which is another way of saying 0 is greater than 1. Well, 0 is not greater than 1, so this one gives us a false statement. So it's not true. Therefore, none of the points on this side of the line work. Now we go to the other side. Well, let's check 2, 2. 2 is greater than, oh, I'm sorry. I picked the point wrong. Should have been negative 2, 2. So negative 2, 2 means that 2 is greater than negative 4 plus 1, or negative 4 is greater than, I'm sorry, 2 is greater than negative 3, which is true. This is correct. So that means that all of the points on this side of the line are valid. They all work, they're all correct. And that's it. So when solving this, basically you just color in everything on this side of the graph. So all of these points work, and all of these points do not work. Yeah, this is the idea behind solving these inequalities graphically. Okay. But it's the exact same process. We take an inequality we make it into an equation, and we solve that equation, and those solutions create boundaries, which in this case is just a line. And then we have to test on every side of those boundaries, and all of the points on the side that work also work, and all of the ones on the side that didn't work don't work. So the one extra kind of step up from this is systems of inequalities. So what if we don't have y greater than 2x plus 1? Say we have y is greater than 2x plus 1 and y less than negative 1/2 x, I don't know, minus 2. So in this case, we have two different inequalities, and we actually do the exact same thing. We set both of them into an equation, and let's do it like this. So we have the first one is y equals 2x plus 1. And the second one is y equals negative 1/2 x minus 2. And then we find the solutions. So graph the green one again. And the red one. So y-intercept is negative 2. And for every 1 we go to the right, we have to go down 1/2. So every 1 we go to the left, we go up 1/2. So we can go to the left 2 and up 1. 2 more and up 1. This line looks something like that. These are our boundaries. So once we have these boundaries set up, then we do our test points. But now we've got 4 different regions, so we've got to check all 4 to see if we have anything that works. So points that I would suggest, again, it doesn't matter, you just have to check 1 in each region. Let's check that one, that one, that one, and I don't know, this one. I like checking the ones that are along the axes because when you check points along the axis, you see that there is one of the 2 variables is 0. So let's label our quadrants 1, 2, 3, 4. So let's test quadrant 1. The point is -2, 0. Well, let's plug that in and see what happens. -2 and 0 means that 0 is greater than -4 plus 1. So it works for this equation. For this equation, -2 times -1/2 is +1. So this point would be -2 times -1/2 minus 2. That gives you -1 is greater than 0. So this point does not work for the second equation. And in order to work for a system of equations, it has to work for both of them. So that is the wrong region. Let's try number 2. So this point is -5, 0. So we know that this point works for this one, but when we plug it in down here, we have -5 times -1/2 gives you +2.5 or 2.5. Subtract 2 from that and you get +0.5 is greater than 0, which is true. So these both work. And if you go through and you find, you test the other points, you'll actually find that they won't work in these equations. So the answer is all of the points in region number 2. So all of these points are answers for that inequality. Yeah. So this is the last little bit that we were going to be talking about for this this chapter, is these inequality things. So yeah, this is how inequalities work. And in your book, they talk about this stuff. This is chapter 6.5. I know it's really random, but this is where it comes up. So in answer to your question, you can record the class if you want to, but again, I record it and post it to YouTube, so that's kind of up to you. So yeah, if you want to record the class, then you are welcome to. But like I said, I post it to YouTube on that link that I sent out to everybody. So up to you. Let's see. Want to check. So I think that's going to be it for today. If you guys have any questions or comments, we're going to be doing review for our test on Friday, and then the online test will be open all of next week. So you guys can, like we discussed the last class period, you can go on and take those at your leisure, whenever is good for you. But yeah, so they will be open from next Monday to next Friday. You can go on and take your attempts whenever you want. But yeah, so other than that, that's all I've got today. And you guys have a good rest of your afternoon. All right, y'all take it easy.